Tips for efficient lysis of tissue samples using the Monarch Genomic DNA Purification Kit. Sample lysis is an important and often overlooked step during the purification of genomic DNA. Cell membranes and extracellular matrix components must be fully disturbed, and proteins and RNA must be completely degraded to ensure that genomic DNA is fully exposed and available for capture by the column. Lysis of tissues can be especially challenging. In this video, we will provide some tips to ensure the proper lysis of your tissue samples. The success of the lysis step is dependent on input amounts, which differ based on the tissue type. Using excess material can overload the buffer chemistry and clog the column, resulting in low yields and poor DNA quality. For example, DNA-rich tissues like spleen, liver, and kidney will become extremely viscous during lysis, which can prevent efficient digestion of the tissue if the recommended input amounts are exceeded. Please reference our recommendations for sample inputs online to ensure that you use the correct amount of starting material. When you are ready to begin processing the tissue, the sample should be cut into small pieces and processed in a 1.5 ml microfuge tube. After adding the tissue lysis buffer and proteinase K, the sample should be mixed thoroughly. Make sure there are no tissue pieces sticking to the bottom of the tube, as these will not lyse efficiently. If there are pieces on the bottom of the tube, vortex to resuspend them. When lysis is carried out using a thermal mixer, it is usually complete within 30 to 60 minutes. You can proceed from here with the purification procedure and you will have excellent results. However, if time is not limiting, lysis can be extended for up to 3 more hours to obtain even higher yields and the lowest possible RNA content. If you do not have a thermal mixer, you can use a heat block for lysis. Vortex the sample every 20 to 30 minutes to speed up lysis. Lysis is complete when the tissue pieces are gone. RNase A should be added at the end of the lysis step to prevent it from being degraded by the proteinase K. By the time lysis is complete, the RNA is released from the tissue and is readily accessible for enzymatic degradation. When working with fibrous or fatty tissues, or with samples stabilized with RNA later, free-floating insoluble fibers will form during lysis, producing a turbid appearance. If these fibers are not removed prior to loading the lysate onto the column, they will stick to the membrane and prevent DNA binding, effectively reducing yield and quality. To remove the fibers, centrifuge the lysate for 3 minutes at maximum speed and transfer the supernatant to a fresh tube before adding the binding buffer. For some of these tissues, the recommended input amounts are lower in order to minimize the fiber formation. If these inputs are exceeded, it may not be possible to sufficiently remove them. We hope that these tips have been helpful. If you have any questions, our scientists are ready to help. Contact us at info@neb.com.